I'm just going to do a few more examples here. I know that you're struggling with how to do some of these combined log, trig, power rule functions. So let's just take a look and go super slowly through how to do these. Maybe we can use a pencil. So f of x, and if I wanted to do 5 times sine of x, I know that derivative. So I'm actually going to leave that alone because that one I know that when it comes time to derivative, I have it down. This one I want to rewrite because I have this power that I want to rewrite as a coefficient, 2 ln x. And now I could take this derivative. So 5, the derivative of sine x is cos x. And here I have 2, derivative of ln x is 1 over x, so 2 over x. Move on to the next one. Here I have ln 2 as a coefficient, and the function, the part that has the derivative, the variable, is the x cubed. So I'm actually going to handle this the same way I would normally handle any numerical. This thing is just a constant. So h prime of x is going to be the power times the constant, so 3 ln 2, times my variable, and reduce the power by 1, right? Decrease the power by 1. So this is just a coefficient, and there's my actual function. And here again, similarly, this is just another constant called k prime. Okay, and I know the derivative of e to the x is just e to the x, and the constant stays, ln 3. So picture these as little coefficients, if you will. The derivative of them is just the same as it would be if I had a 5 or a 12 or any other number there. In this case, I'm going to come in and rewrite the original function. I have ln, and my argument is a constant. Pi happens to be a constant, times x. So I'm going to write this as a ln pi plus ln x. And here I'm going to write this radical reciprocal as a power. So minus 2. Well, I have the cube power and the square root. So x to the negative, because it's in the denominator, cube power, square root. And now I take the derivative of this rather simply. This thing is just a constant. Derivative of a constant is just 0, so it disappears. Ln 1 over x, ln x is 1 over x. Here we're going to multiply negative times a negative coefficient, so plus 3 halves times 2. Well, over here, 3 halves times 2, the 2's are going to cross out, plus 3x, and then I need to subtract. I have negative 3 halves minus 2 over 2, so minus 1 is negative 5 over 2. If I want to rewrite this in non-power form, I have 1 over x plus 3 over, and I have the square root of x to the 5th. Now, I wanted to point out here, and I did another, this appeared once on another worksheet, is that if I have the square root of x to a 5th power, I can really break that down as the square root of x squared times x. And when I really have the square root of a square, meaning that x can pop out. Okay, so I have really x squared root x. If that piece that was popping out was an odd power, I would have to use absolute values.